Centrifugal pumps are widely used in industrial applications. A centrifugal pump will operate trouble-free for years with the proper monitoring and maintenance. However, pumps will need servicing eventually, like all machinery. This program presents information that allows an operator or mechanic to troubleshoot possible causes of pump problems before excessive damage occurs. Upon completion of this course, you will be able to identify potential problems, disassemble a centrifugal pump, and inspect and assess the condition of centrifugal pump components. A trained operator should be able to identify and sometimes correct potential problems or secure the pump before extensive damage can occur. As the operator monitors a pump, his sense of touch and hearing can be an important asset. By listening to and touching the pump casing, bearing assembly, motor, and associated piping, the operator can identify symptoms such as excessive vibration, abnormal noise, or abnormally high temperatures. Monitoring such symptoms can help an operator to identify potential or actual problems. Larger pump systems may have telemetry equipment to remotely monitor these indications or locally mounted instruments that can be read and recorded by the operator. A pump's temperature is monitored by touch or by reading locally installed, handheld, or remote sensing thermometers. An infrared pyrometer may also be used. A motor that is running hotter than usual may indicate the pump is drawing more than normal power. A motor running hotter than usual could be caused by pumping too viscous a liquid, causing the pump to work harder. A too tight packing gland, causing additional friction and requiring more power to rotate the pump. A binding rotor, requiring additional power to turn the pump. Or a pump at runout on its performance curve. High motor temperatures can indicate motor winding defects causing overheating. A malfunctioning voltage or speed regulator causing the pump to run at a higher than normal speed. Problems with frequency, or low voltage or a voltage imbalance to the motor. Pumps can be sealed with packing or mechanical seals. When packing is used, check for signs of a hot stuffing box or overheated packing. These signs include little or no gland leakage, a high-pitched chirping or squealing from the stuffing box, steam or smoke coming from the stuffing box, or excessive temperature read by instrument or noted by operator. A hot stuffing box can be an indication of too tight or insufficiently lubricated packing, wrong type of packing, or misalignment of the packing gland in the stuffing box. When mechanical seals are used and a leak is detected, the cause for the leak must be identified. Examination of the mechanical seal for any damage is essential so corrective measures can be taken. Consult your seal manufacturer's specifications and procedures for details. An overheated bearing can usually be detected by the increase in lube oil temperature leaving the bearing housing or localized bearing temperature when a telemetry system is used. In general, a bearing whose oil temperature increases 50 degrees Fahrenheit or more as it passes through the bearing or is too hot to touch has already failed or is ready to fail. Bearing outlet temperature can be reduced by a combination of any of the following actions in accordance with the manufacturer's instructions. increase the amount of oil flow in a large system, direct cool air over the bearing, apply damp cloths to the bearing housing, slow and or gradually stop the pump. Other indications include a metal-to-metal rubbing or squealing sound. A hot bearing housing can be an indication of too much or too little lubrication, or improper, poor grade, or contaminated oil. It can also be caused by misalignment at the bearing or coupling. Excessive vibration and noise in the pump casing may be indications of cavitation. Cavitation is the formation and collapsing of vapor bubbles due to insufficient net positive suction head, or NPSH. Cavitation can be caused by a lower than needed suction head. This may be due to a low tank or reservoir level, or an uncovered suction line requiring the reservoir to be filled to the proper level to provide the correct net positive suction head. Until the reservoir can be filled, throttle back on the discharge valve. As the discharge is decreased, the operator will be able to hear the cavitation clear up. Obstructions on the suction side of the pump, partially closed valves, plugged strainers, and even higher than normal pumpage temperatures can contribute to cavitation problems. Vibrations other than cavitation may be indications of misalignment between the pump and motor, worn or loose bearings, components bent or out of balance, or resonant or natural frequencies in the piping, support components, or other machines. Air entrainment is the presence of air in the suction line, possibly due to a leaking flange or union drawing air into the system. This can lead to reduced discharge capacities and a lower discharge head. This problem may be corrected by tightening flanges and couplings in the suction line and, if necessary, coating the flange edges with a sealant until the flange gasket can be replaced. The flow rate of the pump can also indicate possible problems. A low flow rate can be an indication of air leaks in the suction line or stuffing box, a speed regulator malfunctioning, a partially plugged suction or discharge line, insufficient suction head, a damaged or clogged impeller, or wrong direction of pump rotation. The discharge pressure of the pump can also give early indication of a problem that affects the pump's efficiency. Low discharge pressure can indicate air entrainment, cavitation, damaged or clogged impeller, low pump speed, excess capacity, or wrong direction of pump rotation. Some problems may require the pump to be inspected to determine if the actual cause is within the pump itself. During an inspection, the pump's internals can be checked for signs of abnormal wear, premature breakdown of material, or reasons for a catastrophic failure. Small pumps may be replaced or removed for repair at an off-site facility. Larger pump work will be done on-site. Prior to working on any system, ensure that proper personal protective equipment, or PPE, is available. It is important to know the characteristics of the system you're about to work on and the exact nature of the fluid. What is the temperature of fluid? Is it hazardous, caustic, toxic, or flammable? Is it an environmental hazard? The Material Safety Data Sheet, or MSDS, for the liquid should always be consulted prior to any exposure, and the suggested precautions for handling, cleanup, storage, and disposal should always be followed. Make sure that sufficient ventilation exists prior to venting any system that contains flammable, caustic, or toxic fluids. Prior to disassembly, the pump must be mechanically and electrically isolated. Close and tag shut all suction, discharge, and recirculating valves, as well as any external sources of cooling or lubrication. Do not rely on a check valve as an isolation valve for maintenance unless it can be secured in a closed position. Open the electrical supply breaker and install a tag and lockout device. Disconnecting the power cables completely from the motor may be required. Much of the work on centrifugal pumps will require removing the rotor from the casing. Depending on the type and design of the centrifugal pump being overhauled, this may require the casing half stuffing box cover, suction cover, or in some cases the casing cover to be removed. Slowly open the casing vent to depressurize the system. Then open the casing drain to transfer the fluid to an appropriate container. At this point, to gain full access to the pump, it may be necessary to remove portions of suction and discharge piping or external lubrication lines. Oil contained in the bearing housing will need to be drained and inspected. This can be done before or after the pump has been removed, taking into account the possibility of environmental contamination. To remove oil from the bearing housing, remove the drain plug and drain the oil into an appropriate container. Retain the oil for inspection, checking for excessive wear byproducts, metal filings or chips, as well as signs of excessive dirt and water. This is a good indicator of the bearing condition. After the oil is drained, replace the oil drain plug. Once the work area is clear, the pump must be disconnected from its motor. Prior to disconnecting the pump-to-motor coupling, match mark both halves of the coupling. This will help to orient the coupling components when the pump is reinstalled. After marking, remove the coupling bolts. Inspect each bolt and nut for damage. Identify any fasteners that need cleaning or replacing. Store the nuts and bolts in a container for reinstallation later. Many smaller single-stage pump bearing assemblies can be removed from the casing, or the entire unit can be removed from the base plate. This will allow the pump to be disassembled on a workbench. When removing the pump from its base plate, ensure that any shims on the motor that are in place are marked for the mount or bed plate position at which they were installed. When working on a workbench, make sure the pump is secured. Clean, sanitize, or neutralize any residual contamination on the pump components, and be sure to follow the recommended MSDS procedures. Using the manufacturer's procedures, begin disassembling the pump. Remove the fasteners from the casing at the casing split. Inspect the fasteners for damage. Store the parts in a marked container for reassembly. Remove the casing half or casing access as applicable. Larger pumps, especially those that require a split casing half to be removed, will need a lifting device to remove the casing half. Most pumps will have jacking bolts to break the seal between the casing halves. Run the jacking bolts in slowly and evenly to prevent cocking or binding the casing as it is lifted. Once the casing seal is broken, the casing can be lifted off. Any approved device can be used to lift off the upper half of the pump casing. If eye bolts are not part of the pump casing, it may be necessary to install them. Once properly attached, the device must lift the casing half evenly. It is important to avoid damaging the pump internals. Once the casing half is clear of the pump internals, it is swung out of position and lowered onto wood staging blocks to protect the parting flange. Clean old gasket material from the parting flange surfaces using a scraper and emery cloth. Inspect the seating surfaces for nicks, dents, or cuts that may need to be repaired. Some pumps may have impellers held in place by impeller retaining nuts. Other pumps may have the impeller threaded onto the rotor. The manufacturer's procedures must be followed when removing the impeller. Proper technique for removal will be noted, as well as the correct tools to be used. Be sure to turn whatever fastener is used in the correct direction. Take special care not to damage the impeller during the removal process. Do not strike the impeller with a hammer or mallet, and do not heat the impeller to remove it unless specifically recommended by the manufacturer. Place the impeller removal tool on the driver end of the rotor, positioned approximately 12 o'clock. Manually spin the impeller and shaft assembly in the correct direction to unthread it from the rotor. The impeller removal tool will strike the workbench or floor, causing the impeller to break loose and unthread. This may have to be repeated to loosen the assembly. To remove an impeller with a retaining or cap nut, place the impeller removal tool or proper size wrench on the driver end of the rotor. Place the proper wrench on the cap and break the nut loose. Continue to unthread and remove the nut. It is important to note that there is always the possibility that some pumpage may have leaked into the cavity between the impeller nut or impeller hub and the end of the shaft. Use caution when removing these parts in a hazardous liquid application. Grip the impeller on opposite sides and pull it off the rotor. Some pumps may require a special impeller pulling tool to break the impeller loose from the shaft. Remove the impeller. Now, remove the old O-ring or gasket and inspect the seating surfaces for damage. Set the impeller aside for inspection and cleaning. If the pump has a stuffing box, remove the packing gland retaining nuts. Inspect and store in a marked container for reassembly. Remove the gland or gland halves from the stuffing box. Clean and inspect them for damage or excessive wear. Remove packing using a packing removal tool and set aside for inspection. If equipped with a mechanical seal, follow the seal manufacturer's recommendations and disassembly procedures. The bearing frame or housing supports the bearings, provides a clean environment for them, and may act as a lubricating oil sump. Remove the bearing housing bolts. Using jacking bolts, draw the bearing assembly from inside its frame. Support the bearing assembly as it is withdrawn from the frame and continue to pull the shaft assembly from the pump. There may be multiple bearing housings or assemblies that will have to be opened on large pumps. To allow the shaft assembly to be lifted from the casing, the thrust bearing housing and one or more journal bearing halves may require removal. Remove a snap ring or similar device which secures the housing to the bearing assembly. Pry off the thrust bearing seal from the shaft. Inspect the seal for wear or damage. Slide the thrust bearing housing from the thrust bearing and shaft. Inspect the housing assembly for wear or signs of particulate or water damage. Remove any retaining nut, along with the lock washer, from the thrust bearing. Inspect the threads for wear or rust damage. On pumps with ball or roller bearing arrangements, the bearings will have to be pressed off the shaft. In some cases, this can be done by using a bearing splitter to allow the shaft to be pushed through the bearing race. Mount the shaft and bearing assembly in the press and press the thrust bearing off the shaft. Once the shaft is free from the thrust bearing, the forward bearing can also be removed. Inspect the bearing for indications of lubrication or misalignment problems. Large pumps may have large thrust bearings that will be rolled out once the pump rotor is lifted to remove the weight from the bearings. Once the bearings have been removed, clean and inspect all parts. Once the shaft has been cleaned, inspect it for telltale signs of abnormal wear. Check the drive end coupling. If the shaft has become rough and undersized, this indicates the coupling has been wobbling. The keyway may also have been enlarged by the wobble of the coupling. Check the thrust bearing area of the shaft for signs that the bearing may have moved. If the bearing has moved, the area may be rough and undersized or stained with a brown rust-like mark called fretting. Also check the retainer threads for damage. Check the inboard bearing area for signs that it may have spun on the shaft. Check the diameter and finish of the shaft in the seal area. If a mechanical seal was used, check for indications that it may have moved. The set screw may have scored the shaft, or there may be fretting. If packing was used, check for excessive wear in the area that the packing contacts the shaft or shaft sleeve. Check the shaft sleeve area for excessive wear. Check the finish of the entire shaft. Any significant scoring or damaged threads may require the shaft to be repaired or replaced. Inspect the impeller mounting area for wear and possible pitting. If an O-ring is used, check the seal area for signs of wear. Also check the impeller retaining threads for any sign of damage. Inspect the impeller for wear and specific types of damage. Check for pitting in the vanes and other surfaces. Pitting may destroy the edges of the vanes and cause surface roughness, leading to lower pump efficiency. Pitting may also occur in the mounting area. Check the O-ring seal area for damage that would prevent sealing. Also check the retaining threads for damage. Extensive deep pitting may significantly weaken the impeller. In such cases, the impeller should be replaced. Erosion due to abrasives in the pumpage often occurs on the impeller. This can produce grooves in the surface of the vanes and a loss of surface area, increasing the gap between the sealing areas. This increases impeller clearances and may cause a loss in pump efficiency. Impellers that show extensive signs of erosion should be replaced. An important check is the wearing ring clearance. This can be checked with the pump partially open or when it is fully apart. Check the manufacturer's specifications for the tolerances in this high wear area of the pump. Clean and inspect the pump casing. Look for signs of pitting, which can weaken the wall of the casing. Another common area for pitting is in the impeller to casing interface area. If deeply pitted, the casing is weakened and may need repair or replacement. Scoring may also occur in the impeller interface area. Scoring can be a sign of misalignment of the impeller, improper impeller clearance adjustment, or abrasive solids that have been trapped between the impeller and casing wall. This type of wear also reduces pump efficiency. The inlet and outlet flanges should be checked for smooth sealing surfaces. The stuffing box and gland should be checked for signs of damage. Examine mounting flanges and other surfaces for burrs and corrosion, and clean as necessary. Inspect mechanical seals for excessive wear, hairline cracks, cuts, nicks, or roughness of the sealing surface. Due to the close tolerances used in manufacturing, mechanical seals are rarely reused. Many manufacturers offer rebuilding kits consisting of new elastomers and seal faces to bring them back to a like-new condition. Inspect the pump frame flanges and bearing seat areas for burrs and cracking. Light burrs can be filed or stoned away. Inspect the bearing bore areas for proper diameter and concentricity. A badly spun bearing can cause dimensional problems or scoring. These bearings should be repaired or replaced. Once damaged parts have been repaired or replaced, the pump is ready for reassembly. This program presented information on troubleshooting, disassembling, and inspecting common centrifugal pumps. You have learned to identify symptoms, causes, and ways of correcting abnormal conditions. You also learned through inspection to check for signs of abnormal wear, premature breakdown of material, or reasons for a catastrophic failure. You should now know the precautions to take in the isolation and disassembly of a centrifugal pump, including safety and environmental concerns, and how to inspect used oil for contamination. You have learned how to disconnect the coupling, component piping, and when necessary, how to remove the pump from its foundation. And finally, how to handle bearing, impeller, and mechanical seal removal and inspection, as well as inspecting components for erosion and corrosion. A detailed understanding of a centrifugal pump and its components can slow or eliminate losses in pump efficiency and even catastrophic failure. Your ability to diagnose, inspect, and repair is an integral part of your company's maintenance training program.